Welcome to Brain Bite. Subscribe for fascinating science, history, and mystery videos. When you picture the beginning of everything, you likely imagine a time when there were no stars, no planets, and no space, suddenly interrupted by a fiery explosion expanding into a dark void. This common mental image fails to capture the physical reality of our origins. The Big Bang is the rapid expansion of space itself. Every region of the universe expanded at once, carrying all matter and energy with it, leaving the cosmos with no single central origin point. Because time and space were created during this event, there was no outside for the universe to expand into, and no before the expansion began. If there was no explosion to witness, and this all happened 13.8 billion years ago, how can we be certain that this event actually occurred? In the 1920s, astronomers realized that distant galaxies are actively moving away from Earth. Astronomer Edwin Hubble observed a specific pattern using the massive mechanical telescopes of the era. He found that the farther away a galaxy is, the faster it appears to recede from us. This chart shows the relationship between a galaxy's distance and its recession velocity. The clear upward trend reveals a physical history. If everything is spreading apart today, the universe had to be smaller and denser in the past. By taking that velocity data and mathematically reversing it, we can trace the expansion back to a single starting point on our timeline. Reversing the recorded expansion suggests that everything in the cosmos originated from a single, unimaginably hot and dense state. Running the clock back to the beginning reveals a universe 13.8 billion years ago that was a hyperdense speck of pure energy, burning far hotter than the center of any star. From this extreme starting point, a basic thermodynamic rule guided the evolution of the cosmos. As space expands, its temperature drops. During the first tiny fraction of a second, the expansion caused the universe to cool enough for raw energy to condense into the first physical matter, fundamental building blocks known as quarks and electrons. Within minutes, those individual quarks joined to form protons and neutrons, which then bonded to create the nuclei of the absolute lightest elements, hydrogen and helium. This rapid early cooling permanently set the chemical makeup of the early cosmos. It explains why hydrogen and helium remain the most abundant elements in the observable universe today. For the next 380,000 years, the universe was an opaque, glowing fog of charged particles. It was so hot and dense that light photons could not travel. They were immediately reabsorbed in constant collisions with the plasma. The expanding universe eventually crossed a temperature threshold that allowed electrons to lock on to atomic nuclei. This formed stable, neutral atoms and cleared the cosmic fog. As this diagram illustrates, once the fog lifted, light was finally able to travel freely. This burst of ancient light has been moving through the vacuum of space ever since. In 1965, researchers testing a massive radio antenna in New Jersey detected a faint, mysterious static coming from every direction in the sky. Arno Penzias and Robert Wilson identified this omnipresent static as the cosmic microwave background, the exact signal early models predicted would remain from the early universe. Physically detecting this afterglow provided the specific piece of data required to validate the Big Bang model over competing theories. With the universe now vast and transparent, gravity began pulling enormous, dark clouds of hydrogen and helium gas together over millions of years. As the gas clouds condensed, the pressure at their centers became intense enough to ignite the universe's first stars. Looking inside one of these stars reveals a massive forge. The extreme heat of nuclear fusion forces lighter elements together, building heavier elements like carbon, oxygen, silicon, and iron. When these massive first-generation stars exhausted their fuel, they collapsed and exploded as supernovae, scattering those newly forged heavy elements across space. This process provided the complex chemical materials required to build solid planets and support biology. Around 4.6 billion years ago, a cloud of this heavy element material collapsed to form our Sun and the Earth. This leads to a staggering biological reality. Every atom in your body, except for most of its hydrogen, was forged inside the cores of those ancient stars. Our understanding of the cosmos continues to evolve. We now know the expansion of the universe is accelerating, driven by a mysterious force called dark energy. While physics can map everything from the first fraction of a second onward, the ultimate trigger of the Big Bang itself remains a profound unknown. The expansion that began 13.8 billion years ago remains an active process that we are intimately connected to today. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications for more amazing stories.